Also related to a construction we did earlier in the course, if you construct the angle bisector, any point on the angle bisector is the same distance from the sides. Now remember, we measure distance at a right angle. So that tells us F to D and F to E are the same. And then the converse of that kind of goes along the same way. If you have a point inside the angle and it's the same distance from each side, then that point has to lie on the angle bisector. So if we take a look at example 5, we want to find the distance from D to B. Well, notice it's AD is the angle bisector because it bisects this angle. So that means B to D is the same as D to C. So D to B equals 5. If we take a look at angle WYZ, we're supposed to find that. Well, notice point W is the same distance from each side. So that means that WY is the angle bisector. So angle WYZ is the same as WYX, which is 28 degrees. And then we can kind of do the same thing that we did with perpendicular bisectors. We have to do a little algebra here. Notice P to S is on the angle bisector. So that means Q to S equals S to R. So Q to S is 4x minus 1. S to R is 3x plus 2. Well, let's solve for x first. So let's subtract 3x from both sides. 4x minus 3x is x. Minus 1 equals 2. Let's add 1 to both sides. X equals 3. But we're supposed to find Q to S. So Q to S is 4x minus 1. So 4 times 3 minus 1. 12 minus 1 is 11 for Q to S. And there's your answer.